Hello all, welcome to the next subtopic of electrostatics, and in this subtopic we are going to learn about Gauss law. Note one thing, whatever we are going to study from subtopic 8, subtopic 9, subtopic 10, these all things are removed from our syllabus. This is not there in the new revised syllabus of 2020 to 2021. This portion is removed because of COVID pandemic. Gauss theorem is not there in our syllabus. Then also we are learning why, because of entrance point of view we are understanding the Gauss law. First we will be observing what is the statement of the Gauss law. Gauss law is actually a mathematical theorem. Was a mathematician. Gauss was a mathematician. What Gauss stated, if suppose this is an arbitrary shaped conductor means any shaped conductor. So if suppose I deposit a plus q charge on this conductor, so the property of the conductor is the plus q charge will be uniformly distributed over its surface. Plus q charge will be uniformly distributed over its surface like this. So plus q charge is going to be distributed. Now you have also studied the electric lines of forces. Now electric lines of forces, they are perpendicular to the surface and away from the surface if it is positive charge, and it is towards the surface if it is negative charge, right? So electric lines of forces, you know the direction and you know the properties of electric lines of forces. Now if suppose I consider this force, if I consider this line, so I will get that not only one line is coming here, there are bunches of lines. What are there? There are bunches of lines. So this bunches of electric lines of force, this is called as tubes of force. What it is called as tubes of force. So what is there inside a tube? So if suppose I consider this tube, if I consider this is what a tube, a cylindrical shaped tube, so there are many electric lines of forces are present. There are many electric lines of forces are present inside that tube. So inside that tube there are many electric lines of forces are present. Okay, now if suppose I consider for that particular area, if I consider this particular area of the conductor, if I consider this particular area ds of the conductor, what I am going to get is, I will get normal electric induction. What I will get? Normal electric induction. So what is normal electric induction? Electric induction is nothing but number of tubes of forces. Electric inductions are nothing but number of tubes of forces. Number of tubes of forces. Why this is called as normal? Normal means what? Perpendicular. Normal means what? Perpendicular. So since these tubes of forces are perpendicular to the surface of the conductor, we say this is what? Normal electric induction. Okay, and the short form is NEI. What is it? Is NEI. So from this, if I consider for this is for small surface ds, if I consider the total surface of the conductor S, so that will be called as total normal electric induction. What it will be called as total normal electric induction. The T stands for total. T will stand for total. Total normal electric induction. Okay, so this was all about the introduction to the electric induction. If you want, you can take a note of this. This is not there in our syllabus now. So we understood first what is called as electric lines of forces. Electric lines of forces. Now electric lines of forces is nothing but single line. But if I observe, there is not a single line is present, but there is what a tube of line is present. That means there are more number of lines are present in one place. So we say the second one is tubes of forces. This is called as what? Tubes of forces. tubes of forces. Tubes of forces means what? Bunch of lines. Next, we understood what is called as normal electric induction. Normal electric induction means what? Normal electric induction denoted by NEI. So, what is normal electric induction? Number of bunch of lines. That means what? Tubes of forces. Number of tubes of forces in a particular area. In a particular area. And the last one we studied is total normal electric induction. It is what total normal electric induction. So what is total normal electric induction means? The total normal electric induction means this is what TNEI, total normal electric induction. What this means? Number of tubes of forces in total area. Number of tubes of forces in complete area. Okay. So in complete area, if I consider, then that will be called as total normal electric induction. But we are studying what? Gauss law. So what Gauss law means? Gauss law indicates total normal electric induction. It gives you the formula to calculate total normal electric induction. Okay. So let us understand what is Gauss law. Let us understand what is called as Gauss law. Now this is what a conductor, arbitrary shaped conductor. Arbitrary shaped conductor means any shaped conductor. Let it be a circle, it be a triangle, a cuboid. Okay. So this is what a plus Q charge is getting deposited on the surface of the conductor. Now what is the property of the conductor? The plus Q charge will be uniformly distributed over its surface. Plus Q charge will be uniformly distributed over the surface of the conductor. Now the question is, what is total normal electric induction of complete surface S? So this is what a complete surface S. So what is the total normal electric induction of this complete surface S? So by Gauss law, we can say that the total normal electric induction over a complete surface S is nothing but the amount of charge deposited on the conductor. The amount of charge deposited on the conductor. So suppose I deposited plus Q1, so this will be plus Q1. Again, if I deposit plus Q2, this will be plus Q2 will be added. If I again deposit plus Q3, again plus Q3 charge will be added. If I deposit minus Q4, then this will be minus Q4 like this. So if you want the count, the total normal electric induction count over a complete surface S, if you want the count, it is nothing but the algebraic sum of all the charges. The algebraic sum of all the charges. So there's nothing but the summation of charges of I, where I take value 1 to n. If suppose there are n number of charges present. If I consider this is plus Q4 and up to plus Qn charges are there, so I can say this is what? This is total normal electric induction. Total normal electric induction of the complete surface S. It is given by the summation of Qi where I take value 1 to n. So this is what Gauss law. So if you want to write the statement, what the statement will be? So the statement is the total normal electric induction. The total normal electric induction of a complete surface S enclosing a charge. So this is very important. The surface should enclose the charge. Okay, where the charge should be present? The charge should be present on the surface of the conductor. The total normal electric induction of a complete surface S enclosing a charge is equal to. So if suppose I write like this mathematical statement, if I write mathematical expression, what it will be? Mathematical expression. Mathematically, it can be expressed as total normal electric induction means total normal electric induction of a complete surface S. So I can say of a complete surface S. So this is what total normal electric induction of a complete surface S is equal to. So I have written what is equal to algebraic sum of. So this is nothing but the algebraic sum of, that means the sign of summation. Algebraic sum of all the charges enclosed on the surface. Algebraic sum of all the charges enclosed on the surface. Getting or not? So that means if suppose plus q amount of charge is deposited, so plus q2 amount of charge deposited, plus q3 charge is deposited. So this is nothing but the algebraic sum of all the charges. That means the value of qi, where I take value 1 to n. So this is nothing but your Gauss theorem. This is nothing but your Gauss theorem. Okay. So you can pause the video, you can complete the things down. Okay. This is important for entrance point of view. Gauss theorem is very important for the entrance point of view. This is the diagram from the book. You can see that if suppose I want to calculate the total normal electric induction for a small surface ds first, and then we will calculate for s, but the derivation is not in our syllabus, so we are not interested in getting the derivation, knowing the derivation. Okay, so the next topic that we are going to learn is nothing but electric dipole moment. What it is? Electric dipole moment. Electric dipole moment. Again, this is not there in our revised syllabus, but we will understand this by entrance point of view. Okay. Thank you so much, all of you, for paying attention. Goodbye.